It is Microphone Monday, and today we have the Sony C37A tube microphone. Very different in terms of other mics you might be used to. This came out in 1955, and the Japanese engineers at Sony and the brass wanted to start doing condenser mics similar to what the Germans and Austrians were doing, but they took a totally different approach. The first being they used a capsule very unlike the German mics. And as I've talked about in previous ones, on the German microphones, you look at the M7, the K47, the K67, you have either a single or a dual back plate, and then there is a diaphragm on both sides. This microphone only has a single back plate with a single diaphragm. And the result is a couple things. First off, they're not terribly directional. You know, the high end is a little directional, but it's not terribly directional for a condenser mic. It's a very straightforward circuit, by the way. And let's talk about how that, and this is the other big difference. So the German mics use what's called a plate-loaded circuit. This uses a cathode follower circuit. A plate-loaded circuit, which is the overwhelming majority of tube circuits, the tube has an element called a heater, which then, above that, the cathode then releases electrons up towards the anode or the plate. But in between is an element called a grid. And in a microphone, the capsule is feeding the grid. The signal is going to the grid, and those electrons that are passing through the grid are amplifying the signal. It's technically called an impedance converter at that part of the circuit, but it's amplifying it. And then once you come off the plate, you're going to the rest of the circuit, to the output. Now, in a cathode follower, you're kind of going backwards, and you're taking the output off the cathode instead of the anode. And the result is, first off, the gain is a lot less, but it's a lot more linear, allegedly, and the headroom is a lot higher, so you can give it a lot more signal without distortion. The other effect is, because the signal is less, your signal to noise ratio isn't as good. So these can be very noisy. These use a 6AU6 tube, which are not the quietest tube. You may have to go through a bunch of them to find a quiet one. There is a very rare version of this with an AC701, which is a very quiet tube, which I believe were broadcast versions, which helped take that noise floor down a bit. But essentially, it's noisier, and that's just part of the equation. You have to know that your noise floor isn't going to be as low as a U67 or M49 or anything. But the other byproduct of having a cathode follower is the impedance is such that you can put a really long distance between the tube and the output transformer, especially because in order to get these mic so small, the output transformer is in this power supply. And you could get cable lengths of up to basically 30 meters they would supply that you could put between the mic and the power supply, which is where the output transformer is. Now, this is the first generation of, there's three different versions of these power supplies, and they have a high-pass filter built in. We are in what is called M2, and M usually stands for music. There's M2, M1, and V. So M2 is basically their full range. Then you go to M1, which takes some of that low end off. And then you go to V for voice, and you can hear it is a lot thinner. It is rolling a lot of the low end off. And the way that it achieves that is there's always something called a output coupling capacitor between the tube and the transformer that blocks direct current from going into the transformer and destroying it. But it has a coupling caps have a very symbiotic relationship with the transformer in terms of the frequency response, and whatever value they arrived at is what this is right now. And there are two more capacitors in there that as you turn this, they add it in sequency, which then raises your capacitance. And every time you raise the capacitance, then the access point of whatever frequency that is for the low pass filter, for the high pass filter, keeps moving up. So the higher the frequency for the high pass filter, the less low end there is, and that's what you are hearing. Now the later versions of these use a different circuit for that filter, because they also put a low pass filter in. So instead of simply having capacitors, they've added an inductor into the circuit. And when you use an inductor for your EQing, you're going to introduce more phase shift, and it's going to have a different sound. A lot of people say these are the best sounding, and that may also be because the transformer might be different. But one thing that I've seen that they all have is paper and oil coupling capacitors, and those have a definite sound. And I remember one time I tried for fun, what would it sound like if I put some high quality Mylar capacitors in the output cap, and all the magic was gone. There is a certain resonance, it sounded like, I don't know, it's some type of harmonic distortion, something that was part of the magic of this mic. And then when I put these high quality Mylar caps in, it just got very surgical and pristine, and the magic was gone. So that's a big part of the sound of these. And anybody who really knows what they're doing with electronics will tell you that the coupling capacitors definitely are one of the more audible parts of any circuit. So, what else have we got about these guys? I love them on, my exposure to them is on tom-toms. The first time I ever saw one, I was like, that's the greatest tom I've ever heard. And I love these on toms. You can see there's an old picture of Earl Palmer on a Wrecking Crew session. This is the one overhead. The great vocal mic. I don't know what song it was for. There's a picture of Sinatra singing into one of these, but I do like these on vocals. I like them on acoustic guitars. I've used them on mandolin. Very interesting piano thing going on. And the response of these is very different. It's much flatter than your typical German or Austrian mic. And one thing that's interesting is, so there's a little bump around 8K, and there's a bump around 15K where it then starts to tail off, which is actually higher than most German mics kind of start to taper off around 12K. So they're a little more open on top, a little flatter on response, and because they have such high headroom, you can put them on loud sources, you can put them on a guitar amp, you can put them on a number of things. There is the next version was the C37P, which was solid state, and then I believe there's one called the C37 FET, and this capsule, which I think is called the C3, wound up in several iterations later on of various mics. I think it's a C38 and a C48. I'm not quite sure. But they're very good sounding capsules. People are trying to make recreations of these, and I'm not going to step into the fray about how successful they are or not. I have not really had a chance to sit down with them all and do some A-Bing, but there are recreations out there. And I understand it, because when I got my pair, they were really cheap, and they've kind of gone through the roof. They've kind of gotten up there with, U67s and stuff in terms of price. But they're wonderful mic, and I think that's all we got on the Sony C37A. I love the fact that I put out what knowledge I have, and I learn new things when I'm wrong. I am always very happy to be wrong about something, and that's how I learn new stuff. And it was like my mistake with the Hart custom flanger. So my friend Tim Campbell reached out to me and told me I had it backwards with the C3 capsule in this C37A microphone. I said that the rear ports open up to create Omni, which was sort of what I'd read, but it didn't quite make sense because anything that's coming in off the backside with a single diaphragm would be out of phase. But I thought maybe there's an acoustical labyrinth that is delaying the time enough that it is not out of phase, that it arrives in phase, or in relative phase, I should say, to not cancel. But it didn't quite make sense, but I just went with it. So apparently, when the port is closed, that is not when it's in cardioid. When the port is open, it is in cardioid because it is really an Omni capsule, and then when the port opens, then enough signal is arriving out of phase to cancel whatever is coming from behind here. So if you hear, as we turn this thing, I'm going to give you the demonstration, you can hear my voice, and it's got a pretty wide pattern, but as I get to the back there, that back is definitely out of phase. So, because that rear port is open and that sound pressure is arriving 180 degrees out of phase from whatever's entering the front. So let's close the rear. I got to mute this because it's very noisy when I do it. Now the rear is open. Now it's not really true Omni because you can hear the difference between the front and the back and the front. We've lost a little bit of low end, but it's pretty more uniform to the sides and definitely does not reject off the back. So that is Omni-ish. But the interesting thing is, even though it's missing some low end, which would be consistent with an Omni microphone, because a real Omni mic does not respond to proximity effect the same way that a regular LDC dual-sided mic or anything, or cardioid mic will. So that bass is staying rather consistent no matter how far or how close I am. So that is true Omni in that sense. But the interesting thing is the top end of this is pretty similar to the cardioid, and that, which is very unlike your usual large diaphragm condenser, where they will get brighter in Omni. So let's just listen to the difference. We're about a foot away right now, right? We're a foot away. And let's see what that bass response is and how flat it is from one sound to the next. So I'm going to mute this again while I switch back. And that's about, that's pretty similar. So that's pretty remarkable that what they did is flat across, but now the proximity effect is back. That wasn't there before. So there you have it. Some insight into the C3 Sony capsule inside the C37 various family, C38, C48 microphones. Very cool invention. And and one other thing Tim pointed out to me, Tim Campbell, who my buddy, who is a really brilliant capsule manufacturer, that even though this is a 34 millimeter capsule, which is the same as the K67 and the K47 and all that, the back plate is actually smaller. It's more of a medium diaphragm capsule. So even though the mylar is larger and stretches over that, the effective back plate is much smaller, and that helps with the omni response, because most true omni microphones are either medium or small diaphragm. And I believe some of the technology in this was already in some of the Schoeps microphones that had come out previously. So they may have borrowed from the Germans after all, more than I thought. There you have it. There's my correction of incorrect information. And thank you, Tim, for teaching me something new that I can... more useless information that I'll carry on. All right. Have a good one.